All right, here are solutions for quiz 3 for Math 243. We're given some data here. Doesn't really matter what it is, but it's income in the story. It's income in thousands of dollars for 13 randomly selected people named Kobe. This is Kobe Bryant's salary in 2012, I believe. Anyways, doesn't matter what the data is. First thing you're supposed to do is create a 5-number summary for this data. Okay, what a 5-number summary is it's the minimum, the first quartile, the median, the third quartile, and the maximum. And you can, a couple ways to get this. Maybe I'll say can get from TI under one variable stats. So I think that's what I'll do. That seems the easiest. So I got calculator here. The way you do that, first thing you want to do is hit stat and under edit put all your data in. I've already put all this data in, but you can go ahead and do that same thing. And then back under stat, if you go to calc, and the first thing listed is one variable statistics, and you're supposed to tell it what list your data's in. If you don't, it defaults to L1, so since mine's an L1, I didn't have to tell it, but just to be complete, I put an L1 there, hit enter, and it kicks out all sorts of information. You scroll down here, these last 5 numbers it gives you is your 5-number summary. So in this case, I'll switch colors here. Our minimum was 0, that's easy enough. Our first quartile was 41. Our median is 48. Our third quartile is 61. And our maximum is 30,450. So since this is in thousands, this is a little over 30 million, which is what Kobe Bryant makes, which is ridiculous because he's over the hill. And the nice thing about this is TI calculates quartiles a little bit differently than your book does, but with 13 observations, the way your book does it and the way your TI does it is identical. So whether you did this by hand or using your TI, you should get the same answer. Next one, the interquartile range. The interquartile range is equal to Q3 minus Q1. Is the difference between your third quartile and your first quartile. And since we just calculated those above to be 61 and 41, we could say that our interquartile range is 20. Easy enough. Argue whether interquartile range or standard deviation is a better measure of spread for this data. So the basic idea is use interquartile range, or use standard deviation if your data is approximately normal. Use interquartile range if the data is skewed or you're worried about outliers. This data is pretty skewed. It's definitely got an outlier up here, but it's pretty skewed even without that. Well, maybe it's more symmetric without that. But the point is, because the data is, let's see, this would actually be right skewed because we have few high observations, but most of the data is to the left. Because the data is right skewed, maybe I'll write or because of the outlier, the large observation, interquartile range is a better measure of spread. The reason why is interquartile range is resistant to outliers. Our first quartile and third quartile didn't change because of this huge observation here. It's 41 and 61, but if this were, I don't know, 105 or 92 or something like that that was more reasonable, these would still be the exact same number, so our interquartile range wouldn't change. This huge number is definitely going to change our standard deviation. So that's why we want to use interquartile range so it's not as affected by that one huge observation. So where was I? I guess we argued that interquartile range was the better measure of spread. So moving on, calculate the upper and lower fences and identify outliers. All right, our upper fence is equal to the third quartile plus 1.5 times our interquartile range. And our lower fence is equal to our first quartile minus 1.5 times our interquartile range. And what's good is that we've already calculated all these things. We know that the third quartile from above was 61. The first quartile was 41. And then we want to add our interquartile range was 20. So 1.5 20s is 30. So 61 plus 30 is 91. And 41 minus 30 is 11. So here are our fences. So any observations that are less than 11 or greater than 91 would be considered outliers. So going back to your data, it looks like 0 is the only outlier on the lower side, but 100 and 3450 are all outliers. Maybe may all be outliers. May be considered outliers. Good enough. And calculate a box plot for this data. And we have that one absurdly high observation. Don't be too worried about that one being to scale. But sure, we can do that. We got our lowest observation was 0, and then most of our observations are within 100. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And I can just do this by hand. We have that 41. So 41 right around in there. And 61 are our first and third quartile. And 48 was our median. So maybe that's right around in there. Can label those points as 41. What did I say? 48 and 61, I think. And then what we want to do is make lines go out to our smallest observation that's not an outlier. So 0 is an outlier, so 25 is our smallest observation that's not an outlier. So 10, 20, 25 would be right in there. And then our largest observation that's not an outlier looks like it's 62. So something like that, 62. But then we got these outliers. We have one down here at 0, one up here at 100, and then one way out here at 30. What do we have? 30,450. And yeah, those aren't to scale. Sometimes what you do when it's not to scale is you kind of put a little squiggly line here. But whatever, I don't really care. Draw anything that looks anything like that. And you got yourself a box plot. I guess you could check your answer on your calculator, although it might look a little bit weird with that huge observation, but let's try it. If you hit second and then y equals, you get into stat plots. If you hit enter on stat plots, we can turn the first one on and make it the fourth type, because our fourth type is a box plot. Our data is in L1, so everything else looks good. So all we gotta do is create the correct window, which we can do with zoom, and then zoom stat, which you get to if you scroll down to 9. If you hit enter, well, it doesn't give you a great picture because we have this one observation way out here. So what we can do is we can change our x minimum to maybe -5 and our x maximum to 105. And that won't show our last observation, but at least it shows the rest of them. You can kind of trace that if you want to check your answer. We had our median was 48. Our first quartile was 41. Our smallest observation that wasn't an outlier was 25. Our minimum value was 0, this outlier here. Then we had our third quartile was 61. Our largest value that's not an outlier is 62. And then we got this x value out here of 100. And even though you can't see it on the graph, if you go right one more, you get our other outlier of 30,450. So there's our box plot. That's the end of this quiz.